for the problems that are in the Unit 1 test review. So in this first question, it says solve for x. So remember, when we're solving for x, we want to first isolate the absolute value. So we're going to do that by going ahead and dividing both sides of this equation by 2. So when we divide both sides of this equation by 2, we get the absolute value of 3x minus 9 is equal to 15. So now to solve, we need to go ahead and separate this into two equations. So we have 3x minus 9 equals negative 15, and 3x minus 9 equals 15. So now in order to solve for x, I'm going to start off by adding 9 to both sides. And when I add 9 to both sides, I get 3x is equal to negative 6. Now I need to divide both sides by 3, so I get x equals negative 2. Over here, I'm going to do the same steps, so I'm going to go ahead and add 9 to both sides. When I add 9 to both sides, I get 3x equals 24. And now I need to divide both sides by 3, so I get x equals 8. So now in this equation, we once again need to solve for x. So we're going to start off by isolating the absolute value, which means we're going to add 4 to both sides. So when you add 4 to both sides, we get the absolute value of x plus 3 is equal to 11. So we can now separate this into two equations. So we have x plus 3 equals negative 11, and x plus 3 equals 11. So now we can go ahead and solve for x. I'm going to subtract 3 from both sides. And when I subtract 3 from both sides, we get x equals negative 14. Over here, we need to subtract 3 from both sides. And when I do that, I get x equals 8. So in this problem, it says a machine fills jars of soap. The weight of jar and soap should have a combined weight of 24 ounces. If the total weight is more than 0.5 ounces different from the desired weight, the jar of soap is unacceptable and removed from the product line. Write an equation that can be used to find the lightest and heaviest acceptable weights of the jar of soap. So we can model this using an absolute value equation because we have a central value, which is equal to 24, and we also have a range that's acceptable, which is 0.5 ounces. So if I write this as an equation, it's going to be the absolute value of x minus 24 is equal to 0.5. So in this problem, it says the proper temperature for serving soup is 104 degrees Fahrenheit plus or minus 10 degrees. What's the minimum proper temperature for serving soup? So once again, we have a central value, which is 104, and then we have a range, which is equal to 10. So if I write this as an absolute value equation, I can write the absolute value of x minus 104 is equal to 10. And so I can now actually separate this into two equations so I can solve. So I have x minus 104 is equal to negative 10, and x minus 104 is equal to positive 10. So I can solve this equation now by adding 104 to both sides. And when I add 104 to both sides, I get x equals 94. And over here, when I add 104 to both sides, I get x equals 114. So notice the minimum temperature here is going to be 94. So 94 degrees Fahrenheit is the minimum proper temperature for serving soup. So where on this number line would you find points that satisfy the inequality the absolute value of 5x minus 10 is less than or equal to 15? So here we have a less than or equal to, right? So that means we're going to write this as an and compound inequality. So I'm going to write this as negative 15 is less than or equal to 5x minus 10, which is less than or equal to positive 15. So remember, we can solve this by working on isolating the variables. So I'm going to start off by adding 10 everywhere in this compound inequality. And so on the left side, I have negative 15 plus 10, which is negative 5, less than or equal to 5x, which is less than or equal to 15 plus 10, which is 25. Now I need to go through and divide by 5. And when I divide by 5, I get negative 1 is less than or equal to x, which is less than or equal to 5. So since I have a less than or equal to sign, I need to use a filled-in circle. So I have negative 1. And then I have positive 5 as my endpoints. And remember, any number that is in between these 2 points, okay? Any number that's in between here is going to be a solution to this inequality. Okay, so now let's solving this inequality. So the first thing I'm going to work on doing is isolating that absolute value. So I'm going to start off by subtracting 5 on both sides. So I get 4 times the absolute value of x minus 3 is less than 13 minus 5, which is 8. So now I need to isolate the absolute value by dividing everything by 4. So I get the absolute value of x minus 3 is less than 2. So since it's a less than, I can write this as a compound inequality, negative 2 less than x minus 3, which is less than positive 2. And I can now solve this by adding 3 everywhere. And when I add 3 everywhere, I get 1 is less than x, which is less than 5. That is the solution to this inequality. Okay, so now let's solve this inequality. So once again, when we're working with inequalities, we want to start off by isolating the absolute value. So I'm going to subtract 7 everywhere. So I get 6 times the absolute value of x minus 2 is greater than 24. And so we can go ahead and divide everything by 6. And then we get the absolute value of x minus 2 is greater than 4. So since this is a greater than sign, we can write this as an or inequality, right? So we're going to say x minus 2 is greater than 4, or x minus 2 is less than negative 4. So now we just go ahead and solve, which we can do by adding 2 everywhere. So when we add 2, we get x is greater than 6. And then we have or, our other solution. When we add 2, we get x is less than negative 2. Okay, so that's going to be our solution to this inequality. So now here we want to solve for x. So this is an absolute value equation. So I'm going to go ahead and separate this now into two pieces. So I have 8x minus 9 equals negative 7 and 8x minus 9 equals positive 7. So to solve, I'm just going to go ahead and start off by adding 9 to both sides. When I add 9 to both sides, I get 8x equals negative 7 plus 9, which is 2. So when I divide everything by 8, I get x equals 2 over 8, and I don't want to leave it like that. I'm going to go ahead and reduce that fraction to 1 over 4 because both of these are divisible by 2. So x equals 1/4 is one of my solutions. Over here, I'm going to go ahead and add 9 to both sides. So when I add 9 to both sides, I get 8x equals 16, and then I'm going to go ahead and divide everything by 8. So that gives me x equals 2. Okay, so here, following inequality and graph the solution on the number line. So I'm going to write this as an and inequality. So it's negative 53 less than or equal to 8x plus 5, which is less than or equal to 53. So I'm going to start off by subtracting 5 everywhere. So when I subtract 5 everywhere, I get negative 58 is less than or equal to 8x, which is less than or equal to 53 minus 5, which is 48. So now I'm going to go ahead and divide everything by 8. So when I divide everything by 8, I get negative 58 over 8, which is less than or equal to x, which is less than or equal to 48 over 8, which is 6. So negative 58 over 8, I'm not going to leave it like that. I'm going to go ahead and reduce it. So if I go ahead and reduce, both of these are divisible by 2. So I have negative 29 over 4. So I have actually as my solution, negative 29 over 4 less than or equal to x, which is less than or equal to 6. So if I graph it on the number line, I need a filled-in circle at 6. Negative 29 over 4, we can convert that to a decimal. I'm just going to show you how to do that real quick. So 4 goes into 28 7 times, and then we have 28, and then if we subtract, we get 1, and then I'm going to put a decimal here. So if I have 10, and then 4 goes into 10 2 times, 4 times 2 is 8, and then I subtract 2, I bring down another 0, 4 goes into 25 times, so negative 7.25 will be the answer if I convert it to a decimal. Okay, so I'm just going to go over here and put this second filled-in circle a little bit past negative 7, and then any number that's in between these 2 points is going to be a solution to this inequality. Okay, so now let's work on solving this for m. So this is actually a compound inequality. Notice there's no absolute value signs. It's not an absolute value inequality. It's just a compound inequality that's an and inequality. So I start off by working on isolating the variable, which means I'm going to subtract 5 everywhere. So I have negative 25 minus 5, which is negative 30, less than 3m, which is less than negative 7 minus 5, which is negative 12. Now I'm going to go ahead and divide everything by 3. When I divide everything by 3, I get negative 10 is less than m, which is less than negative 4. And that's the solution.